And then with whatever time we have remaining, I'll put you all into breakout rooms and we'll do the box cost. But both of these are designed very much to get you acclimated to GC. Like we've said, it's a very powerful program, but it does come with a little bit of a learning curve. So I'd like to get you accustomed to it as quickly as possible. Does anybody have any questions before we get started? All right, so if you haven't already, go ahead and open up the coordinate point GC file. Basically, I'm going to show you a few things, and I'm going to just have you try to recreate them. Another thing you might want to have open today is early, maybe the day before the semester started, I sent out a couple of cheat sheets. So whether you have a Windows machine or a Mac, I should have sent you a document that shows a lot of the different keyboard shortcuts you can use. So that might be
talking
helpful.
about the handout, right?
Yeah, I mean, yeah. Yeah, I sent that out as a PDF. So I believe I sent that out the day before the semester started. So go look for January 10th if you are having trouble. Or it's also on, I think Mark put it as an announcement on Canvas. All right, I think I have all 34 of you, so let's get going. I'm gonna go ahead and share my screen. All right, can you all see this?
I can see it.
Cool. All right, so the first thing I'm gonna do is this. Right now, my graph is pretty well blank, and the exceptions are these 3 points here. So these 3 points in purple. So the first thing I would like you to do, and I'll give you a couple minutes to kind of hunt around and look for the commands that get this done. You can also do it with the keyboard shortcuts, or you can use some of it's in one of the menus there. But graph me these 3 points. So I'll give you a little bit to do that. And you know what? Why don't you send me a thumbs up on the reactions menu when you've gotten it.
Done.
Or do that. All right, I got a couple. Okay, I feel like I got a little bit less than half you. I'm gonna go ahead and give it another 60 seconds or so. And then I'll volunteer someone to tell me how this got done.
And I was able to do the point where it says display the portion of curve.
We're gonna hold off on that. So for right now, just because you don't know what portion, I'll show you what portion of the curve I want you to show me. So for right now, just let me see those 3 points.
Okay, it's just I kind of got it all ahead.
Oh, you're good.
It seems that I was not emailed the file.
What was that, Trey?
I don't know if I was emailed the file. I've been looking through my email in spam, trash, everything, and I can't find anything.
You're on your ASU email?
Yes.
Okay. You didn't just join the class today by any chance, did you?
No, I joined before.
Okay, that's weird.
I think you can still get the file in Canvas.
No, I did not put this on Canvas.
Oh, you mean the activity file, not
Yeah.
the cheat sheet file.
Is that the one you mean, Trey?
Yeah, the activity file. I have the
Okay.
GC.
Okay. Trey, can you send me a private message with your Your email, please.
Okay. Yes.
All right, so why does this keep going away on me? That's better. Nope, that's the wrong one. All right, so what command do we need to make this work?
Control 2.
Control 2. All right, so if you do Control 2, basically what that brings up what GC calls a 2 vector. So, or a 2 coordinate vector, basically a column vector. So I'll go ahead and bring up the student one now. Or no, I guess it's here. Come on, GC, play with me. All right, there you go. So, yeah, if you do Control 2, you'll get these things that are called 2 vectors. By default, X coordinate on the top, Y coordinate on the bottom. You can also find it under math. So pretty much everything you can do with a keyboard shortcut, you should be able to find under a menu. Any questions about this first piece here?
I seem to remember GC has a way of plotting multiple points without doing a separate equation for each one of them, but I spaced out on how to do that and didn't feel like spending time looking for it. Do you remember off the top of your head?
So plotting multiple points using a different method than this?
Yeah.
So I think by now all of you have defined functions in GC and graphed them. You can be more specific about, like typically you graph something, you just let GC figure out what the domain is, you just graph the whole thing. One of the things, in fact, you're just about to tinker with it. You can tell GC, what X values you want to graph or what Y values you want to graph. You can restrict it. So having said that, so now I'm showing you a part of this curve here. I am not going to tell you what the curve is, but hopefully you can figure out what function this is based on what those 3 points are. They were chosen
I have
pretty.
a question.
Go ahead, Mark. Mark, you muted
So
yourself.
how do you make the slider appear on my GC? Because it did not come up with my GC.
So I am looking at a different file for you. So the file that I am looking at is basically designed for me to lead you all through this. If you're talking about this,
so my file did not
slider on top, you don't have that.
Okay, just to make sure I didn't miss anything.
No, you're all set.
Okay.
All right, so basically make yours look like mine. Basically, I want to see the proper function graph there, but not the whole thing. So I mean, this function is defined for X values beyond the ones I'm showing you, but I just want to see it for this restricted domain here. So take a bit with that. I'm going to try to get Trey set up without losing my screen.
No, it's not that. Is it okay if I ask what the beginning X value is and the ending X value of this graph, or no?
Take your best guess at it. I tried to make it somewhat apparent, but if that's not the case, then just yeah, take your best guess at it.
You said you wanted the portion showed, right?
Yep, just that portion.
Okay, thank you.
All right. If anybody was sending me a thumbs up, I've been a little bit diverted. Does anybody still need a little bit of time to get this going?
Anytime.
Go ahead and give you another minute or so.
I think I know how to do it.
Dong is asking if you have to figure out the curve. Yeah, try to figure out the curve based on the 3 fixed points that we graphed last time. So 1, 1, 4, 2, and 9, 3. All right, so even though a lot of you have done, only a few basic things with GC to this point, which is fine. I think one of those basic things is graphing functions. So first of all, what is this function that I am showing you a part of right here?
Y equals square root of x.
So y equals square root of x. Good. So square root of 4 is 2, square root of 9 is 3. But if you were to just, put into GC y equals square root of x, you would see, this curve extend down to the origin, and would it extend to the right infinitely. So what do we have to do to get this thing only to show what I am asking for?
I've set the interval so that x is greater than 0.5, but less than 10.
Okay. And where did you set up that interval, Mark?
Well, you said where?
Yeah.
Oh, so I said y equals square root of x, comma, and then the interval.
There you go. So yeah, I mean, and the way it's programmed here is a little different, but I am guessing what most of you who got this going did something like this. Y equals, I forgot this, the shortcut for radical. Is it Control-Shift-R?
Yeah, but the if view is greater than 0, I did not include.
Yeah, I think the most direct way to do it is this: y equals radical x, and then just, 0 is less, or sorry, 0.5 is less than x, which is less than. And if you want to do less than or equal to there, that's also correct. It's just not, it's not going to make enough of a difference to make the graph any more or less visible. Any questions on this piece? So hopefully by now, if I asked you all to graph a function, you could do it with no problem. But maybe I'm guessing for some of you, restricting the domain to a subset is a little new. Any questions before I move on to the next thing here? All right. So 2 down, 2 to go. Last thing I want to do is this. So this might be a little hard to see, but when I hit this play button, you're going to see this black dot moving from the bottom left and moving to the right. Or, so if I hit play, it just kind of goes on its own. Or I can take this slider on the bottom and drag it around wherever I want. So has anybody played with this, sliding point feature in GC yet? Okay, so I think I'm only getting a couple of thumbs up on that question. So what I think I'll do is this. If you want to get this slider involved, I think Mark has mentioned that there are a few things that are, a few letters and names that are reserved for certain things in GC. For example, you know, you can call a constant anything you want except for example, X and Y. I mean, X and Y have very specific dedicated meanings in GC. But one of those things is N. So N is like a parameter. So if you use N as some kind of variable in a function, then it will automatically make this slider show up on the bottom of your screen. I mean, I think it might already be there, but I don't think it can, it's probably all grayed out because it doesn't control anything. So let's just do this first. It's pretty obvious where this sliding point belongs. So based on that, you should be able to make just a very small modification on the graph you just created to make that sliding point. So let's do that first. Just basically put that sliding points on there, and let's not worry about having it actually move around, but let's just see it generate and make sure that it lives on that curve. So I see Alistair saying he set N equal to 0, but you're not seeing a point. So if you set N equal to 0, you need more than one value to give me a point. For example, you know, when you graph this this square root curve, you really have to give me 2 coordinates. So even if, for example, you did N equals a 2 vector of 0, 0, you would get that point, but I don't believe you would have any control over it. So I guess another way I can explain it is this. So we're doing 2 different things here. One, we've already done. We've already graphed this function, this square root function. That square root function, as we've graphed it, is basically a collection of points. They're all graphed at the same time. You can see them all at once. What the sliding point is, it's a single point that I can move around, but you know, it only exists in one place at any given time. So think about what you did to graph that. On my screen, it's a pink line there, that pink curve. Think about what you did to do that. What modification could you make to that command to just give me one point that I can slide around? And Alistair, I can appreciate your analogy when it comes to GC. This is my second time TAing for this class, but last semester I definitely had some fights with it. All right. Does somebody who's gotten this to work want to give me what their command was they got this to work?
You plot a 2 vector where x is n and y is the square root of n.
There you go. So I think that's probably the most direct way to do this. Oh, I know why that view thing was there for me now. It's not going to affect you though. So yeah, movable point here in black. So look at these 3 2 vectors here. These are fixed points. I cannot change those, unless I go in here and edit these values, but these are meant to be stationary. The movable point is all having to do with this parameter n. So if I have a 2 vector where my x coordinate is, you know, something generic n, and the y coordinate is whatever is the square root of whatever that value is, then you will get this black point that you can slide around. Any questions there? All right, last thing I would like to do is this. Actually, I think in the interest of time, I'm just going to, one last thing I want to show you, but I'm just gonna kind of give you this one as a gift. So if you go into graph, basically the axes are there by default, but now I've taken them off. I unchecked that draw axes on the menu there. Oh, what's going on in the chat? For the view, did you just restrict the domain? If you're talking about, are some of you saying that the moving point is disappearing? I don't think the fixed point should be disappearing.
If I try to graph like the movable point, then all like the dots like on the pink line disappear. The points that we graphed before.
That's strange. Let me think about that. That's not automatically clear to me why that would happen. But that's okay. It's not going to hurt us for what we're doing. Last thing I want to show you is this. Now that I've turned off the axes, now as I move this slider around, look at the X and Y axes there. So basically, I'm getting a measurement of basically how far my total change in the X direction, total change in the Y direction. So here's how that's done. Let's just think about it for a second. If I want to graph the X axis, what equation should I give to GC?
Just y = 0.
Y = 0. And similarly, the y-axis would be x = 0. But if you just graph y = 0 and x = 0, you would get these infinitely long lines in both directions. But as you've already seen, you can restrict those domains. So I can graph y = 0, but I want it to go as far left as 0 and as far right as the sliding point. Same with the red line there. I want it to go as low as 0, and I want it to go as high as the square root of the sliding point. But just a taste of a few things you can do with the graphing capabilities in GC. Any questions about any of the things I showed you here? So I don't know if he's done it yet, but I believe Mark will ask some similar things of you very shortly if he hasn't already.
Stephen, I actually have a question on the movable point. Like, so I tried entering that, but mine doesn't actually move. It just stays at the origin.
Okay, so on the slider down here, you have a couple options. So there's this play button. If I hit the play button, it'll just start moving around on its own. Or you can actually grab the slider and move it. So Matthew, if you do either one of those things, do you see any change?
No, like on the movable point step, like I type the n in the square root of n if u is greater than 1, and it just stays at the origin. Like,
so go ahead and delete your if statement. So that should help you, and I'll tell you why I have to have that in there for me. So the reason that made your sliding point invisible is because I have this slider at the top of my GC file, which is different from yours. So this slider here is basically designed so, and it doesn't work anymore because I took out my if statements, but when this slider is at the far left, all you see is the fixed points. When it's in the middle position, you see the fixed points and the curve. And when it's all the way to the right, you see the sliding point. So your file doesn't have that in there, so you don't need those if statements to make this movable point.
The other two parts of that is that you can create variables, not just of letters, but of whole words, and you can create sliders of any variable. So Stephen just put those two pieces together for that part of it.
Oh, okay.
Matthew, is
Yeah.
it working the way you would like now?
Yeah, it's moving now. I see it.
Good.
Yeah. Alright.
All right.
Thank
And more chat stuff. What's going on? Can I scroll down to the limitations on X0 for sure? X equals 0. I believe you're asking about these last two lines. So just like when we graphed the curve that, you know, the portion of that function we wanted to graph, it's really no different than setting the domain or setting the range between fixed values. Now you're just setting it between, you know, one fixed value and one variable value. All right, so any questions before I close this one down? All right, so let's do this. The other one I sent to you, the box cost one, I'm gonna go ahead and stop sharing. Go ahead and open that up. So that one's a little easier to direct on your own. So what I'm gonna do is this. I'm gonna go ahead and stop recording.